Hi everyone. In this video, we are going to discuss about another example of transmission line. The given example is if open circuited impedance ZOC is 900 at an angle of minus 30 degree ohms and short circuited impedance ZSC is 400 at an angle of minus 10 degrees ohms. Calculate characteristic impedance Z0 and the propagation constant gamma of a 12 km long transmission line. So coming to the solution, given that the open circuited impedance ZOC is 900 at an angle of minus 30 degree ohms and short circuited impedance ZSC is 400 at an angle of minus 10 degree ohms, and also given that the length of the transmission line L is equal 12 kilometers long line. So calculate the characteristic impedance Z0 and the propagation constant gamma. So first calculate the characteristic impedance using the relation. We know that the characteristic impedance, given that open circuited impedance and short circuited impedance values are there. So we know that the characteristic impedance Z0 is equal square root of open circuited impedance into short circuited impedance. And substitute ZOC and ZSC values into this equation. We get the characteristic impedance Z0 is equal 900 plus 400. 900 into 400 is 360 into 10 cube. Square root of that value is 600. And what is the phase angle? Minus 30 degrees into at an angle of minus 10 degrees minus 40 degrees. Square root of minus 40 degrees is minus 40 degrees by 2. So that is minus 20 degrees. And this is the value of the characteristic impedance. And we know that next we can determine the propagation constant gamma using the relation. We know that tan H gamma L is equal square root of short circuited impedance divided by open circuited impedance. So what is the substitute short circuited impedance and open circuited impedance values here? And what is the short circuited impedance? 400 at an angle of minus 10 degrees divided by open circuited impedance is 900 at an angle of minus 30 degrees is equal 400 divided by 900, and square root of that value is 0.66. Square root of that value is 0.667, and phase angle is this denominator phase angle is coming to the numerator. We have minus of minus 30 degrees minus 10 degrees plus 30 degrees plus 20 degrees. Square root of at an angle of 20 degrees is 20 degrees by 2, 10 degrees. So tan H gamma L is equal 0.667 at an angle of 10 degrees, and this is the polar form representation. And converting this polar form representation into rectangular form using calculator, 0.656 plus, that is the real part, and imaginary part is 0.1157. So we know that The tan HPL is represented in terms of the exponential term. Tan HPL or tan H gamma L is equal e power gamma L hyperbolic form. E power gamma L minus e power minus gamma L divided by e power gamma L plus e power minus gamma L. So tan HPL, tan H gamma L is represented in terms of exponential. This is the value. And the RHS term is 0.656 plus J 0.115. The RHS term is written as divided by 1. 0.656 plus J 0.115 divided by 1. So using componendo and dividendo rule, using componendo dividendo rule, this value denominator term plus numerator term divided by denominator term minus numerator term. E power gamma L plus e power minus gamma L plus e power gamma L minus e power minus gamma L divided by e power gamma L plus e power minus gamma L minus of numerator term. At the same time multiplying that term, we get e power gamma L plus e power minus gamma L is equal. So what is the value of e power gamma L plus e power minus gamma L? That is the denominator term. Denominator term is 1 plus, and this is the numerator term. What is the numerator term? 0.656 plus j 0.1157 divided by e power gamma L plus e power minus gamma L is denominator term, that is 1 minus and e power gamma L minus e power minus gamma L, that is the numerator term, and the numerator term is 0.656, and at the same time multiplying minus within the bracket term minus j 0.1157. On LHS side, in the numerator, e power minus gamma L plus e power minus gamma L is cancelled. In the denominator, e power gamma L, e power gamma L and minus e power gamma L is cancelled, and the remaining numerator term is e power gamma L plus e power gamma L 2 e power gamma L, and the remaining denominator term e power minus gamma L plus e power minus gamma L 2 e power minus gamma L is equal, and RHS term is 1.656 plus j 0.1157 divided by 1 minus 0.6 is 0.3434 minus j 0.1157, that is equal. On LHS side, numerator and denominator 2 is the cancel. E power minus gamma L is coming to the numerator. We have e power plus gamma L. E power gamma L and e power gamma L, e power 2 gamma L is equal e power gamma L. And the numerator term is the rectangular form and the denominator is also rectangular form. And converting this rectangular form into polar form, and first converting numerator rectangular form into numerator rectangular form into polar form. So the polar form of the numerator term is 1.6606 at an angle of 3.99 degrees divided by the polar form of the denominator term is 0.3623 at an angle of minus 18.62 degrees. So that is equal, on RHS side, 1.66 divided by 0.36, 4.583. This denominator phase angle is coming to the numerator. We have plus 18.6 degrees, 3.99 plus 18.62 degrees, 22.61 degrees. So taking the natural logarithm on both sides, taking or applying natural logarithm on both sides, taking or applying natural logarithm on both sides, we get natural logarithm of LHS term is equal to natural logarithm of RHS term. So what is LHS term? E power 2 gamma L, and natural logarithm of e power 2 gamma L is 2 gamma L. Log e base e is 1. So natural logarithm of e power 2 gamma L is 2 gamma L. So log a power n is log e power n is n log e, and this base is e, so log e base e is 1, we have only n. So 2 gamma L is equal natural logarithm of RHS term. So what is RHS term? 4.583 at an angle of 22.61 degrees. Gamma is equal 2L is coming to the RHS side. We have 1 divided by 2L into RHS term. So this natural logarithm of polar form is converted into so natural logarithm of magnitude, natural logarithm of what is the magnitude? 4.583 plus natural logarithm of phase angle at an angle of theta mean e power j theta. At an angle of theta mean e power j theta. So at an angle of 22.61 degrees, that is e power 22.61 degrees. So natural logarithm of e power 22.61 degrees. So natural logarithm of 22.61 degrees is 22.61 degrees. So but we know that 1 degree is equal 1 degree is equal 5 by 180 radians. 5 by 180 radians. So converting degrees into radians. So 1 degree is equal to 5 by 188 radians. So therefore the propagation constant gamma is equal. So given that what is the length of the transmission line? 12 kilometers long line. L is equal to 12. So natural logarithm of 4.583 using calculator. Simplifying natural logarithm of 4.583 value is 1.5224 plus, now here the imaginary part. Now here the term is coming imaginary part, plus j, and that value is 0. So one after substituting 1 degree is equal to 5 by 180 degrees, we get 0.3946. So what is the L12? 1 by 24 multiplying 1 by 24 within the bracket term, we get the propagation constant gamma is equal 0.0634 plus j 0.0164 per kilometer or kilometer inverse. Now here the length of the transmission line is 12 kilometers long. So that 12 kilometers is long coming to the numerator, kilometer inverse. So this is the value of the propagation constant. So this is the procedure we can determine characteristic impedance and propagation constant from the given data.